Hello, welcome to my channel. In this video, we are going to learn about a Geometry process in Unix using a fork system call. A Geometry process is a process that completed its execution, but it has an entry in the system process table. That means a child process completes its execution and returns the exit status, but the parent process is not ready to receive the exit status of the child due to a parent process is busy or waiting for some I/O to occur. In that state, the child process will enter into a zombie state. A zombie state process do not actually consume the CPU and memory, but it will have an entry in the process table. This entry in the process table is generally removed only after a parent process recognizes the exit status of the child process and then issue appropriate signal to remove the entry in the process table. This diagram demonstrates the zombie process life cycle. Parent process creates a child process using the fork system call. The child process then starts executing the instructions. Then once it completes the execution, it will exit and send the exit status to the parent process. By the time the parent process is in the waiting state and not ready to receive the exit status of the child process. Then in that condition, the child process will enter into a zombie state. In Linux system, we can track the zombie state process by using the command ps-l. When do a zombie state process becomes a problem? If the number of zombie processes are small in number, they are harmless. But number increases, it is difficult to track by the system. And the states of these zombie processes will get recorded in the process table, and the process table gets loaded with the entries zombies. Because the process table is limited in size, this will prevent the system from creating new processes, which causes the system to stop responding. Let us execute a zombie process using a C program. To understand zombie state process, we need to execute the program in the background. Generally, ./a.out is for normal execution of the C program in operating system. ./a.out with ampersand symbol makes the process to execute in the background so that the user will be provided with a $prompt where we can enter ps-l command to list the currently running processes in the system. In that way, we can check the status of the currently running processes. As we have made the program to execute in the background, we can view the status in the foreground by using the ps-l command. C program for zombie state process. After including the header files, the main process creates a child process by using the fork system call. This is the part of the parent process. This is the code for the child process. In the parent process, the first print statement print the ID of the parent process. Then parent process go to sleep state by invoking a sleep system call, and then parent terminates after the specified units of time. The child process print the ID of the child process. It also print the ID of its parent process by using get ppid. Then child process terminates without any delay. Let us execute this program in the Linux terminal. This is the program and it has been compiled. Now I am executing the program in the background so that I will get a prompt to enter my next command. I have entered the command ps-l. The ps-l is displaying the currently running process on the screen. The parent process ID is 754. The child process ID is 755. Now let us see the state of the 754. It is yes. That means the process is in the sleeping state. 755, the status is Z. Z indicates it is zombie process. In that way, we can identify a zombie state process by entering the command ps-l. Enter into zombie state. Upon the completion of the sleep, the parent process comes out and then process is terminated. Now let us see the list of available processes in the system. Both parent as well as the child processes are terminated and no longer available in the process table. This example demonstrates that a limited number of zombie state processes are trackable, but creation of unlimited number of zombie processes will make the system stop. Thank you for watching this video.